2 and 6, very similar from page 390. In number 2, how many grams or kilograms do we want to end up with? We want 4. Our first statement has to be something like x plus y. And you need to identify what your x and y are. X plus y equals 4. What is my x going to be, Georgia? 30% one. So x equals the 30%. And I need to find out how many kilograms of that I'm going to end up with. Because that's what the question says. How much of each one? Y then is going to be, Ava, the 10%. Okay? And again, my answer is going to be how many kilograms of that. It can't total more than 4, right? Biggest is 4. Caitlin, I want to write an equation now using those percents with the 30 and the 10 and what I want my final answer to be. What is it going to look like? How much x?
30x.
How about 0.3? We're going to always change our percents to decimals. So 0.3x plus
10.10y.
10y or 0.1y equals, what percent do we want our final combination of gold to be? The 15?
Yeah. 0.15.
0.15. But this isn't just 0.15. We got to take 0.15 times 4. Because this is 30% of this, whatever it happens to be, and 10% of this one. So it has to equal 15% of what we want our final one to be of 4. This one is just the total. This one is with all the percents. Okay? It has to be that way as we set up our mixture, just like in our notes yesterday we did it. So in this case, if I was solving this, I definitely would either solve in this first equation either for x or y. And I would have said, oh, x equals maybe 4 minus y. And I'd go with 0.3 times 4 minus y equals 0.1y. And now on my calculator, if you don't have a calculator, grab a calculator and let's multiply that. And if we're multiplying it, what did we end up with? Someone have that one for me? We got how much? 6. 6 sounds really big if I multiply so 0.6. Okay? So I'm going to be multiplying here and I'm going to distribute, right? So I have 0.3 times 4 gives me 1.2 minus 0.3y plus 0.1y equals 0.6. Now there are some of you that prefer not to have any decimals in your problem. So you might have multiplied everything here and had 30x plus 10y equaled, in this case you would have had 600. But you can do that and multiply or had 60 here. You could have done that if you don't have that. I'm going to subtract 1.2 from both sides, right? 0.6 minus 1.2 gives me a negative 0.6. Negative 0.3 plus 0.1 gives me a negative 0.2y. I'm going to divide by negative 0.2. Not by the y, just by the coefficient, which is negative 0.2. And I know that of the 10%, I need more of that, right? It came out to be 3 kilograms. Y was 3. It's pretty easy now to figure out how much of the 30% I need because these two together had to add to 4. Okay? So question 6 is very similar to 2. Okay? Let's look at the other one here. Number 9. Oh, number 9. That's a good question. So you have $1,500 for your 2 accounts. No, if I want to use X and Y, X is what percent am I earning interest? 5%. And maybe we even want to use A, right? Because they say account A and account B. Okay, so A is at 5% interest. We got to figure out how much money we have in that, okay? So we're going to have maybe half of 1,500 or maybe 1,500, okay? It has to total to 1,500. Account B is at 4% interest. First equation might be what? Avery. What do you think? Number 9. Our total investments being 1,500. Count A and B together.
Like for the, when we do the,
One of the equations. Let's do the one that totals.
1,500 equals 5% or point.
No. With the 1,500, if you do just 1,500, what adds up to equal 1,500? We're not going to use any percents this time. So I have this money, right? Because this is going to come out to be so many dollars, right? And B is going to come out to be so many dollars. So I'm just going to go A plus B equals, that's one of my equations, right? That's the one similar to like the one we just did. The only thing that's different in this problem is that they don't tell us like the percent times the 1,500, they tell us this interest is 69.50. So in our second equation, it is going to be 0.05A plus 0.04B equals my total interest. In our other problems, they told us the total, like the 1,500 times a percent. They don't tell us what percent we earned. It was a combination, and that's how much interest. Okay, so that one's a little different than the other mixture problems that we saw. Number 10. Lauren, you want to read number 10 for us? I'm not going to solve it. You guys can do that one. We're going to have time to work today. I'll help you if you need. Go, will you?
A group of scientists studied the effect of a chemical on various strains of bacteria. Strain A started with 6,000 cells and decreased at a constant rate of 2,000 cells per hour after the chemical was applied. Strain B started with 2,000 cells and decreased at a constant rate of 1,000 cells per hour after the chemical was applied. When will the strains have the same number of cells?
So we want to know when the cells are going to be equal. Since we're talking about how many cells, we have the cells in A. Do you think standard form or slope intercept for this one when we're thinking about it? Kylie, what are you thinking? For the information they give. So we thinking standard or slope intercept? No. What do they tell us? Do they tell us, like when we were doing the problem, what's the information that they're giving us that would help us decide slope intercept or standard? They tell you what? That we started with 6,000, and what else is happening? Read that next word. And it's constant rate. Where do we use constant rate? What kind of equations tell us constant rate? That's what you got to be thinking about. Slope intercept. This is perfect slope intercept. So when you read the problems and you're trying to think, oh, which form? These, when you have a mixture one, and they tell you that you have one that's totaling something, and then that's definite standard form. This one, number 10, you want to be thinking slope intercept. Why slope intercept? Because they tell us a rate of change. So anytime you see rate of change, that is like red flag to go slope intercept. So the cells in A, what happened, Kylie? We did what? We started, what's our intercept? We started at 6,000 and we are decreasing, minusing what? 2,000, maybe you want to use X here, right? Now we're looking for the cells in B. AJ, what do we know? started where? Started at 2,000. And if you wanted to use H per hour, because each hour, instead of using X, you could use H. It doesn't matter what your variables are. And the question says, when will the strains have the same number of cells? This is a perfect setup. We need to know when cell A equals cell B. We need to know, put this, you should be using substitution. The 6,000 minus 2,000H equals 2,000 minus 1,000H. Could you have used elimination? Sure, that's going to work. The problem is if you eliminate the H's, that's really what we're trying to find is how many hours, right? We just really need to know when are they the same. You're trying to find out what H equals. So you really don't need to know how many cells. It just wants to know how many hours, okay? All right, let's take a look at 12. Number 12. Going with the current and against. Kayakers paddling upstream. If you're going upstream, you're going usually against the current. So if we're going upstream, which one of these would you say was going upstream, the 4 or the 7? The 4. So we're going to have our kayak, right, going against the current, right? So kayak minus the current is equal to 4 miles per hour. And it says the kayakers traveling upstream and downstream below. What is it in still water? What is the speed of the current? Now, when we're going with the current, we are able to go 7. And again, yesterday, as I said, if you're doing elimination, is a perfect way to find the kayak in still water. The most common mistake that people will do is they'll go, oh, they're going 11 miles per hour. That's a little unrealistic. And that this is not K, but it is 2K. And most people, I don't know why, they'll have an algebra student teach you the test. Just get K equals 11 and then they solve the other one. And then they don't even do the check, which is a little unfortunate at this point. But I get it, for some of you, there's just so much extra work, but that's where you're missing the boat on making sure. So in this case, you're going to divide, and you guys should be able to finish that one, okay? Let's look at 13. You got pennies in your jar. 15 total coins, 4.35. First equation, Sam, we wanted to deal with our coins. What do you want to use for variables, for pennies and quarters? P and Q. What does P plus Q have to equal? 15. Next one, Noel, we want to put our value of our coins. How much is each penny worth? So would I put 1 or do I want to use 10 cents? Do you want to use 435 or 4.35? Doesn't matter, you just have to decide. 435. So if we're going to go 435, then I can go with what? 1p plus what? How much is your quarter worth? 25q. If I don't want to deal with the decimals, 1p, 25q, or you could have had, right, this equation being 0.01p plus 0.25q equals 4.35. Are you going to get the same answer both ways? Yes. This one was just everything was multiplied here by 100, okay? Then the last one we want to look at, 22. My hint in 22 is that it is a mixture problem. One with the ounces and then one with the cost per ounce. So this is a mixture, and we will look at it possibly when we come back. And I will